Hello, this video is we can learn about DFC. Uh, what is DFC? This is the example. And sorry. The first search is DFC. Is a graph traversal algorithm widely employed in graph theory to explore nodes and edges within a graph. The fundamental idea behind DFC is to delve as deeply as possible into a branch of the graph, then break and explore other branches. The main steps of DFC encompass first selecting a starting node. First, a starting node is choosing the commence the search, and second, marking the node. The starting node is marked to signify that it has been visited and processed. And third, exploring and marking children. The algorithm traverses among children neighbors. Is the example of the starting node. If an unmarked child node encoded, it is selected and marked. Fourth one is recursive processes. The marking step is retired and some logic of DFC is applied to chosen child node recursively. This recursive process continues. And 5 is backtracking. After all children of a node have been visited, the algorithm backtracks to explore other alternative paths. These advantages of DFC include its simple implementation, the ability to delve deep into nodes, and low memory usage. However, it does not guarantee an optimal solution for certain problems like the short path problem. A sample implementation of DFC is as follows. Yes, I created the DFC, and if visited is none. And ABC, EABE, CAFG, the last session, DB, EB, FC, GC. And start vertex is equal A. In this example, starting from node A, we traverse the graph using the DFC algorithm. The output displays the ordered visited nodes. DFC finds application in a broad range of scenarios, particularly in problems involving connected components, cycle detection, and topological sorting. A graph of this algorithm can serve as a valuable foundation when addressing graph-related problems. Yes. I read this time and I asked the ChatGPT, can you give me a basic practice question on DFC? Yes. This is the number and my example A, B, D, E, C, F, G. Okay, I solved this problem. Yes, this function uses deep first search to traverse the graph, count the number of connected components. The DFS function is a recursive helper function to explore nodes in the graph. The main function iterates through all nodes in the graph and involves DFC and unlisted nodes, incrementing the count of connected components each time DFC is initiated from visited node. When you run this code with the provide example, it should output two indicating that there are two connected components in the graph. Yes, I write the connected components graph. Deep first search is an algorithm used to graph data structures, primarily designed from exploring nodes in a graph. When employed for the purpose of finding connected components, DFC follows the strategy that connects nodes within the same connected component by traversing the graph. The algorithm begins with selecting the starting node. This starting node can be arbitrarily chosen, and DFC proceeds by exploring other nodes, starting from these initial nodes. As nodes are visited, they are marked to keep track their exploration. This marking is used to check whatever a node has already been discovered. DFC can be implemented either recursively or using stack. The main principle of the algorithm is to visit a node, then explore its neighbors. Within each visited node, the algorithm discovers unvisited neighbor nodes. This involves determining unvisited neighbors of a node depending on structure of the graph. Yes, and run it. When DFC has explored all nodes within connected component, that component is considered complete. A separate process is undertaken for each connected component, and the same process is applied to other connected components. Upon the completion of traversing the entire graph or discovering all connected components, the total number of connected components is obtained. This count represents the solution to the problem. Yes, this problem. Yes. Select 2. Which page? Yes, your implementation should two sides of the connected components. Yes, 0, 1, 2, and this is 2 components. And upon the completion of traversing the entire graph or discovering all connected components, the total number of connected components is obtained. The time complexity of DFC is often expressed as big O notation is n plus e, where n is the number of nodes and e is the number of edges. Space complexity depends on the data structure is used. Okay, thank you. Thank you. These steps represent fundamental states, and DFC undergoes while finding connected components. And this algorithm is commonly used in graph-related problems, especially for determining the number of connected components. In this example problem, the application of DFC to find the number of connected components in a given graph is demonstrated. And we find the output components in the graph. Yes, it is to complement the alternative. Okay, thank you. This algorithm is DFC. The DFC function is a recursive function that performs deep first search. It takes a node and a set of visited nodes as parameter. It starts by adding the current node to a set of visited nodes and recursively calls itself for each unvisited neighbor of the current node. Visited nodes, this is a set to keep track of nodes that have been visited during NDF's traversal. Yes, but I am asking to GPT, what is the visited nodes? Visited nodes. Yes, I'm reading my question. And again, the output loop iteration through all nodes input the graph for node in a graph. For node in a graph. Yes. For each node, it's check if the node has been visited. If not, it integrates a DFC traversal by calling the DFC function with the current node and the set of visited nodes. After the DFC traversal for component, it is completed. It increments the connected components count. And the DFC traversal as implementation by the DFC function start from the unvisited node explored neighbors and marks them as visited. This process continues until all nodes in the connected component have been visited. Each time the DFC function is called, it explores a new connected component. The function returns the total count of connected components found in the graph. An example graph is provided and the count connected components function is called with this graph. The result is printed indicating the number of connected components provided graph. In summary, this Python code uses depth first search to find and count the connected components is unduplicated graph represented as adjacency list. It employs a recursive DFC function for traversal and keeps track of visited nodes to identify and count the connected components. The example usage demonstrated is function with a sample graph. This solution uses and you see the deep first search, the traversal, the graph and mark visit nodes. The connected components function iterates through all nodes, and I asking the ChatGPT. Connected components is it in the graph, yes, I'm thinking this is true. A graph is the adjacent representative of graph. Node is the current node beginning in visited. Yes. And the output should be 2, indicating that there are 2 connected components in the graph. Thank you for this conversation. Thank you. Yes, smile. Thank you, listening and watching. And bye bye. These next homework. See you.